Hi, I am Soroush, and this is joint work with Dominik Peters, Anson Kahng, and Nisarg Shah. We consider the problem of designing voting rules that aggregate agents' ranked preferences and arrive at a randomized decision to select a winner. So, given the rank preferences, we want a probability distribution over the alternatives that achieves high social welfare or some notion of fairness. But how can we evaluate social welfare or fairness here? We assume that the rankings are induced by some utility function that is hidden to us, and for instance, in practice, it is easier to elicit rankings than asking for exact utilities. So we want to somehow maximize social welfare or fairness based on these hidden utilities, and for these goals, we mostly study two objectives. The first one is distortion, and the distortion value of a rule is the maximum possible ratio between the social welfare of the optimal outcome and the social welfare of the outcome selected by the rule. Boutilier et al. Proposed a rule that achieves a distortion of square root m log star m, where m is the number of alternatives, and this works under the assumption that the utilities of each agent sum up to 1. They also showed a lower bound of square root m. We closed this gap by proposing a rule that achieves the optimal distortion of square root m, and it also works for a broader class of utilities. For fairness, we mainly focus on the notion of proportional fairness, which was first proposed in network theory. We show that there is a rule that is order of log m proportionally fair, and that this is the optimal value. To find out more, please come to our talk. Thank you very much.